So 13.3, we're going to be looking at quadrant angles, reference angles, and then we're actually going to construct our unit circle for the first time, and we're going to talk about that a little bit. So quadrant angles, we've kind of talked about already. Those are the angles formed in the coordinate plane that are like 90, 180, 270 degrees. So they're all on like an axis if you're looking at like that terminal side, or measured in radians, 0 radians or 2 pi technically all the way around. Pi over 2, pi, or 3 pi over 2 radians. And those are helpful angles just to know. You're going to see them a lot, and especially when we're working with radians, we're going to get pretty comfortable with the idea of pi radians is 180 degrees, and pi over 2 radians is 90. Reference angle is the acute angle or the number of degrees you are away from the x-axis. So this could be like you have a terminal side in quadrant 2. This little green angle is your reference angle. If you're in quadrant 3, this green angle is your reference angle. You wouldn't take this big one to the x-axis because you're just taking the shortest possible route to the x-axis. Or if you're in the 4th quadrant, then you would go here because this route is obviously shorter than going back this way. The idea here is we're going to get pretty, we're going to use this idea to help us out with quickly finding points on the unit circle, which we're going to see in just a second. It's also just kind of a handy way to know how far off the x-axis am I, and that can actually help you develop how far to the left and right you are and how far up and down you are for your angle. So to use this idea a little bit before we put it into a little more practice, we're going to sketch an angle and then find the reference angle. So if we're going 5 pi over 6, we're going clockwise, and this is almost 1 full pi. So we're going this way and then somewhere like this. And if you'll notice, you're 1/6 away from just negative pi. And that's actually what your reference angle is here. Like pi over 6. For negative 100, pretty similar. Negative 100 is going to be somewhere up in here. Your reference angle here is 80 degrees because that's your shortest angle to the x-axis. For 15 pi over 4, 4 pi over 4 is here, 8 pi over 4 is back to where we started, 12 pi over 4 is here, and then 15 pi over 4 is 3 pi over 4 more, so something like this. Your reference angle is going to be pi over 4. Because you are pi over 4 degrees away from the x-axis. So let's develop this idea of a unit circle. The reason we call this circle the unit circle is because it's a circle with a radius of 1. The unit is just kind of the most basic measurement, so in our case it's 1. So what's cool about the unit circle, and what's cool about how trig relates to circles and to graphing, is that we can use these coordinates. Any xy point, so point A, B, this point, C, D, this point, can be found by just taking cosine of the angle for the x part and sine of the angle for the y part. So before we do any of that, though, let's get our nice quadrant angles down. So if our unit is 1, this point A is at point 1, 0. Ask yourself, where would point C be? Well, 0, 1. Point E is at negative 1, 0, and point G is at 0, negative 1. From here, though, we can actually find all of these points pretty easily using our special triangles and trig, because we know how 30, 60, 90 triangles work, and we know how 45, 45, 90 triangles work. So if we want to find point B, we know this is 30 degrees. So in a 30, 60, 90 triangle, we have a hypotenuse here of 1. Ask yourself, if the hypotenuse is 1, what does the short leg have to be? How high vertically are we? Well, using our rule, we know the short leg is half of the hypotenuse, so the y part is 1/2. Also using our rule, we take the short leg times the square root of 3 to get the long leg. So 1/2 times the square root of 3 is the square root of 3 over 2. And now we know that at 30 degrees on the unit circle, the x part is square root of 3 over 2. The y part is 1/2. Also, once you get this memorized, which you really don't have to for this class, but you will in pre-calc, you'll know right off the bat that, well, cosine of 30 is square root of 3 over 2, and sine of 30 is 1/2. Because if you can picture the unit circle, then you get those measurements really, really quickly. Just to show you how this works, we can find point D as well. So for point D, we don't have to really think, oh, this is 120 degrees all the way up here. We can say, well, we're 30 degrees off of C. So that means we're 30 degrees to the left of C. So we're up square root of 3 over 2 units, and we're over negative 1/2 units. To maybe make this a little bit easier, let's find this point. I don't know what we're going to call it, doesn't matter. But if you kind of map it with our point B, we'll notice we're the same distance up in the air. We're still a 1/2 unit up in the air. And then instead of a positive 3 over 2 for our x value, we have a negative square root of 3 over 2. And you can do that to find this point and to find that point as well. What about 45 degrees? Well, for 45 degrees, if the hypotenuse is 1, we know the short leg times the square root of 2 is equal to the hypotenuse. So call the short leg, we'll call this x because it's the x part. X times the square root of 2 equals 1. That means x is equal to 1 over the square root of 2, which is great, but let's rationalize that denominator. So x is the square root of 2 over 2. We could apply that the same exact way to find y, and we would get the exact same answer. So we get the square root of 2 over 2 for y. Let's now, instead of finding this point, let's find this point down here. Instead of going all the way around 315 degrees or negative 45 degrees, let's use the idea of a reference angle to figure out how far up, down, and over we are from our origin. Well, we're the same distance away horizontally, so our x part is still the square root of 2 over 2. The y part is the same distance, only now it's going down, so we'd have negative square root of 2 over 2. Finally, for 60 degrees, it's kind of just backwards from the 30 degrees. Since this was a 30, 60, 90 triangle here, this is like 60, 30, 90. We can basically just flip-flop our x and our y in the first quadrant. It means we're over 1/2 unit, and we are up square root of 3 over 2 units. And once again, if the hypotenuse is 1, the short leg is 1/2, and the long leg is 1/2 times the square root of 3, which is like the square root of 3 over 2. So just using 30 degrees, 45 degrees, and 60 degrees, you're actually going to be able to fill out the entire unit circle kind of based on these ideas. That's why they say if you can memorize the first quadrant, you basically can get the whole thing down if you understand the concept. So let's find point H. Our reference angle is 60 degrees this way. So that means we're still over the same distance. This is 1/2. And then instead of being up square root of 3 over 2, we're down square root of 3 over 2. So if you have your own unit circle, my recommendation would be for you to fill out that entire thing, get all of these places that I missed, and then you can reference that for anything you're working on for the remaining of this class as you go through it. So that's one thing I'd want you to do. Just stop the video now and go right to your unit circle and fill out all of these points.